Hi, everyone. In today's conversation, I'm going to talk about data classification with serverless functions. First, a quick introduction of myself. My name is Yitao Wang, and I work for a fintech startup based in San Francisco. This virtual background shows where I am, but actually I'm stuck somewhere outside San Francisco because of COVID-19. I have about 12 years of experience working on information security. My recent 2 jobs are all in fintech, focusing heavily on AppSec, red teaming, and data security. I'm not speaking on behalf of my employer or making any statements related to my companies. However, I appreciate the help I got from my fellow colleagues to make this talk possible. So let's talk about the agenda. First, I will try to talk about the data classification problems, covering who should be the stakeholders and why data classification should draw their attentions. In part 2, I will cover how companies solve these data classification problems today and what I think the gaps are. In part 3, I will briefly touch on the serverless computing concepts and some other services offered by Amazon Cloud Services. Please keep in mind that this solution is not AWS specific. The same concept could apply to other cloud service providers as well. I use AWS primarily because I'm pretty familiar with it, and I have the demo set up on it as well. I would love to hear the feedbacks from the audience on other cloud service providers as well. In part 4, we'll look into the technical details to further understand how my solution works under the hood. Last but not least, I will cover the current limitations of my solution and talk about future plans. I'm open to feedbacks. Just feel free to reach out to me. We saw this sign a lot, especially in movies, documentaries. This means data behind this label contains some level of sensitive information. Data classification is broadly defined as the process of organizing the data by its relevant categories so that the data might be used and protected more efficiently. It is particularly important when it comes to risk management, compliance, and data security. On a basic level, the classification process makes the data easier to locate and retrieve. Company may be defining their own data control policy to classify the data accordingly. So each company might have different data control policies or different kind of data classification levels. What I typically saw is the classification mechanism that's put data in a 3-level or 4-level system, which generally includes, for a 3-level system, is public, internal, and restricted, whereas the 4-level classification simply breaks down the restricted level to a more granular levels just to allow better controls. There's definitely some cost benefit related to data classification as well. A proper data classification allows your organization to apply appropriate controls based on predetermined categories, and also keep in mind like different controls come with a cost. So you don't necessarily want it to have the same level of control for all kind of data. Some data, such as static content on your website, you want it to be viewable by anyone, but you don't want to actually have someone to be able to change it. That will make a difference if the data is sensitive data or like card holder information, which generally should only be processed by the crypto systems. You should only apply the security control that's required for data that you've classified based on predefined rules. Classify the data so you can save the time and money because you're able to focus on what's important and not wasting your resource and putting unnecessary controls in place. Well, on the other side, we want necessary controls in place to protect sensitive data as well. That means data classification is a fundamental step in cybersecurity risk management. It involves identifying the types of data that are being processed and stored in information systems owned by or operated by your organizations. We heard a lot of data leaks due to improper S3 bucket permissions or unencrypted database backups. One of the reasons these type of incident happened is that the control is not in place for the data that's being stored or processed. In some cases, the people might not even know this sensitive data is out there under these services. To well understand the security risk of data, you would need to ask yourself some questions, such as, what kind of data do you have? Is it intellectual property, PHI, PII, or credit card information, or just public information? And then where do those sensitive data reside? Whether in the database or static storage, or what? And then who have access to it? And can they modify, delete it, or do something about it? And then what your business will be affected, how will your business be affected if the data is leaked, destroyed, or improperly changed? With the answer of all these questions, you may refer to organization's data control policy for gap analysis and further understand which data is at risk and come up with a solution to control corresponding risk. In some cases, data classification is a regulatory or compliance requirement as well, as data must be searchable and retrievable within specific timeframes. The common known ones here are CCPA, GDPR, HIPAA, PCI DSS, and other privacy laws. Taking the CCPA as an example, a California consumer has a right to access and a right to delete their data. To fulfill certain requests, a company will have to keep track of customer data, knowing where the data is processed and how it is processed. A proper labeling and monitoring of the data is the fundamental steps of achieving CCPA compliance. Well, the stakeholders of data classification is listed on this page. So compliance typically needs to keep inventory of the data and define the data control policy, while the InfoSec team implements controls and ensure the data is properly handled and monitored. Engineering team, of course, have to follow the instructions to use and process the data, making sure that the sensitive data is scrubbed from the log files and then proper encryption is used. Management have to care as well, especially the department which oversee the risk. They should have a risk profile based on the data inventory and constantly evaluate the data-related risk. And then external service providers, such as auditing firms or pen test vendors, are also interested in how company handles sensitive information. They would totally appreciate if there's an existing report or a dashboard showing them where the data is and how data is processed. I found one of the report quite helpful from IAPP, and then I've included in the reference of this talk. So typically, data classification needs to be done in the following 3 steps. First, you want to make sure you scan the data storage and do an initial discovery to identify what you have stored. The data inventory should be generated after this step. Second, once you have the inventory, you will need to perform analysis on the data you have and label the data based on the predefined classification rules. Third, there should be an ongoing monitoring mechanism to keep track of the changes, to understand what's newly added and what's abnormal behaviors. Since there's always changes being made, you need to keep iterating steps 2 and 3 just to keep up with the latest changes. There are two ways of doing data classification today. The first way is the human approach, meaning you have internal reviewers, which is human, given access to the data sets and manually review the data source to discover and classify data fields. And then the second, you have this automated approach, which allows third-party software or any software that scans the data set for the similar task. There's some benefit and there's some drawbacks to each solution. I'm going to touch on that in the next slides. So human-based data classification is challenging, especially for enterprise databases, log storages, where the dev lifecycle is so short and the data is constantly changing. Or given the significant number of data fields to monitor, the ability to keep track of and correlate multiple data fields to human is very limited. For policymakers, such as GRC team, enforcing data-related policy to make sure data is compliant with data control policy, retention policy, etc., can be very challenging if there's no automated tool in place. Under this method, employee or contractor will be given access to the sensitive data set to perform the task, which will expose the database to actual risk, such as the insider threats or client-side attacks. Well, this may happen when access is compromised if the user credential is stolen. Think the recent Twitter examples. Think about the most recent Twitter hack as one of the examples. An alternative way is to automate the data classification process. So today, it's typically done using third-party software. It is capable of handling large data sets, but may bring extra risk as well. So in this case, the company has to allow third-party applications to access production database. This may risk data leaving the trusted boundaries. The third-party software might need maintenance, update over time, and result in network traffic to an external server. And then it needs maintenance, and the maintenance will probably be carried by IT or infrastructure team, which requires cross-functional work as well. So with all that being said, an ideal solution should automatically perform the data classification. But compared to deploying a precompiled third-party software in my data center, I prefer a solution that's designed with the risk in mind. So I wrote the sentences here. Imagine you want a summary of a book, or find out the author had a specific idea about some topics. You would either read the book by yourself or have someone read it for you and write a summary. Here we're facing three challenges. First, the book is too long for you to read, but you need the summary quickly. Second, you're not trust anyone. You cannot trust anyone else to read the book for you because they may leak the content. And third, the new version is coming out fairly fast, and then you want to know the content ASAP, and you want to know the changes as well. With all these challenges in mind, you may just want the author to just include the summary at the very beginning of the book. But since he has not done that yet, you need to have some type of magic to look into the book and generate the summary for you. You might just wondering, hold on, what magic was that? Well, such solution does not exist in the real world. It could be made possible within the context of cloud computing. Let me explain why. Here's the overview of my solution. The core of this solution is to have serverless functions, in this case, a Lambda function on Amazon Cloud, to be the actual worker that classify the data automatically, perform the analysis, and generate the alerts and reports within the targeted AWS account. This serverless function is a piece of code that runs within the serverless runtime that's dedicated to this account. So technically, it's part of the infrastructure. Or if you go to my previous page's example, it's part of the book. In step 1, we deploy the Lambda function under this AWS account and grant it the proper privilege to read the data storage services. At this point, the Lambda function is restricted within the account and will send no external traffic or have external dependencies. In other words, the Lambda worker is restricted within my account. The Lambda function can be triggered by a cron job or a system event. When new changes made to the database tables or data storage services, the Lambda function can simply be triggered. I will touch on that later when I talk about Lambda functions. In step 2, once triggered, Lambda function will try to read from data storage services to get the data set. In this step, the function reads about 20 records from each table and process them based on predefined matching rules. In my mind, the rules can be loaded along with the function to the Lambda runtime as JSON or XML, but I'm open to other ideas. Feel free to let me know if you know other better options. In my demo, the match is done through regular expression, but it can be done in other advanced methods such as natural language processing, which I see as a potential updates in the future. In step 3, the function finds some matches. It will try to send out notification to stakeholders. I choose AWS SNS to link to my PagerDuty instance, and I can get Pager notification from there. There's some benefits come with the solution. First, the solution is based on Lambda function, and then it's replacing the manual data classification mechanism with automations. With proper learning and tuning to the rules and signatures, this task can be done fairly fast. This is very helpful to larger data sets with a lot of changes, which is quite typical in today's short development life cycles. This solution is also a more like elegant solution compared to third-party software. It doesn't introduce any pre-compiled code into my production environment to read my database. And I can also leverage the access control from AWS IAM to restrict my Lambda function. Besides, since the security team can inspect the code of the Lambda function, we can clearly understand what this piece of code is doing to my cloud environment. With third-party software, I could hardly see that happening. Here we're talking about some technical details. This slide covers the AWS basics that will be used in this solution. The first concept is the AWS account. On this chart, the account is basically the edge of the entire architecture overview. An AWS account is a container for your AWS resources. You can create, manage AWS resources in an AWS account, and the AWS account provides the admin capabilities of accessing and billing and so on and so forth. It's a logical layer that organizes all your resources. And if you want, you can tie up all the resources to this account and restrict the external access. Next concept is AWS Lambda. AWS Lambda is a computing service that lets you run code without provisioning or managing servers. With AWS Lambda, you can run different types of code with zero administration of any background servers. All you need is to supply the code in one of the language that is supported by the AWS Lambda runtime. This is the core service that we are leveraging in my solution. Next thing is called CloudWatch. CloudWatch monitors the AWS services and resources in real time. You can use Cloud Service to collect and track metrics and send some events. In my case, I use CloudWatch to trigger a cron job to run the Lambda function weekly, or I could use CloudWatch event to monitor database audit logs and trigger the event-driven Lambda function. I would also want to point out the DB audit logs. If it's by default, it's not enabled, but once it's enabled, MySQL audit logs provide the event when table schema changes. Such as new table creation, dropping table, rename table. The way it works is just looking to the SQL statement, such as create, alter, drop, or rename an operation that happens to certain tables. Monitoring the DB table provide the signal to decide whether to trigger the Lambda function for new data discovery. Last is S3. S3 is the storage services provided by AWS. S3 monitoring is a bit challenging since S3 does not follow schemas like databases. But S3 events can also be used to trigger Lambda functions. However, the match of the S3 content may not be as comprehensive since we cannot count on any schema changes when sampling S3 buckets. Again, another future items to work on. From the chart, the first thing I'm wondering, you might wondering how Lambda function is getting triggered. Well, there are two ways of triggering the Lambda function in my case. The first thing is time-based with CloudWatch rules, which means under CloudWatch, there's a cron job that runs the Lambda function on a frequent basis, such as a weekly job. You can take weekly scans over your data set. Or you can have event-driven or event-based triggers. So when something happens to DB audit logs, such as detection of an alter table happens, you then trigger a Lambda function based on that event. And so for Lambda function, the way it works is that it tries to scan different data sets and looking for sensitive information from there. For databases, it reads and monitors the DB schema changes and pulls some data record for analysis. Schema is a good source of truth because it contains metadata about the actual data that's stored in the database. But for S3, the function parses and analyzes the S3 metadata for useful information and sample the S3 files for sensitive data. S3 is a little bit different because it's unlike the database, which has a schema file. S3 only have the metadata, which is defined by the S3 owner when the bucket is created. So it may not, sampling the S3 might not be as effective as scanning the database. So once you have the scan result, or you have the data inventory, or you identified any changes, you want to be able to notify the stakeholders. I picked a few services that could be used in this situation, such as SNS, which is the simple notification service by AWS. you can basically send out notifications using SNS. In my demo, I use SNS to send alerts to PagerDuty where I can get notifications. Or you have a SIEM or any MSSP services, you can send it to the SIEM for integration so that your security operational people will be able to understand or see what data is being changed, or is there any sensitive information contained in the changed data sets. And also you can have Lambda function to generate you a PDF report if you wanted the report for documentation purposes. In this talk, I originally planned a demo, but since like the talk's only 35 minutes, I plan not to show the demo here because I can't fit that into a short time frame. The plan is to upload the demo into a website, and then I'll include the link to the description of this talk. And also I will include the point of the proof of concept code in my GitHub as well. So there's definitely going to be future works related to this, because right now it's basically a proof of concept and doesn't have all the fancy functions in it. The first thing we need is better triggers. So currently the trigger is set up using S3 events or DB audit logs. The current AWS RDS does not have a native cloud event to monitor DB schema changes. I would hope that AWS add it later on so that we can have better triggers that's more direct and easier to set up. The current matching is based on regular expressions just for this demo purposes. But in my mind, the analysis is better done with NLP algorithms. So that's the future improvement items. Again, I'm not an expert on natural language processing. Maybe I can borrow experience. Maybe I can learn a few things or get some help from the community. And right now I've tested it on AWS, but I would hope this would be a universal solution to other cloud platforms as well. I've not tried that on Google Cloud or Azure. Maybe I will be able to get some resource on that and then try some samples on those cloud service platforms as well. I've included 2 pages of references which I use from this talk. There's definitely more things you're able to find online related to AWS Lambda, because this thing definitely get more popular in terms of computing. And I think that definitely there's a lot of interesting topic you could consider with these cloud service providers. And then the cloud's definitely the next security area that people have to focus on. Well, that wraps up my conversation with you guys. And this talk barely scratches the surfaces of data classification problem. I'm hoping to provide a different approach to this known problem, but within the different context of cloud computing. I'm open to any questions and any further discussions. Feel free to reach out to me after this session. I truly appreciate OWASP offering me this opportunity to share my idea with the community. Special thanks to the organizers of AppSec 2020 to make this virtual conference happen, especially in this difficult time. And I would like to thank you all, and let's keep in touch. Hope you all have a safe and healthy in the rest of 2020.